Imagine for a second you're holding a map of a city. You're trying to get to a coffee shop, but every time you take a step, the streets on the map, they shift slightly.
Mm-hmm.
The distances shrink, the clocks on the towers run at different speeds depending on how fast you walk. It feels, well, it feels like a hallucination.
But for over 100 years, that's what physics has told us is reality, that space literally shrinks and time literally slows down.
It's the bedrock of special relativity.
It is. Einstein's train, the light clock, the twin paradox. I mean, we accept these not just as theories, but as the fundamental rules of the universe.
But what if they aren't? What if the map is just drawn wrong?
Ah.
Today, we are digging into a fascinating and I'd say arguably heretical set of documents. We're looking at a physics audit.
And I really love that framing. An audit, not some, conspiracy theory, not a philosophical rant, but a line-by-line technical check of the books.
Exactly.
It feels surprisingly bureaucratic for something that's trying to rewrite the universe.
It does. So we have access to the logs of an independent space-time auditor. It's an AI persona commissioned to review this fierce debate between two very different schools of thought.
Right.
In one corner, you've got the Einstein faction, that's standard theory, and in the other, a challenger known as the Zioned Chat faction, proposing something called the simultaneity point cloud definition model.
Which is a bit of a mouthful.
It is.
So maybe we just stick to the point cloud model for today.
Fair enough. Now, usually when we see these alternative physics theories, they kind of fall apart pretty fast. They misunderstand the math. But the scorecard here is what really grabbed my attention.
Oh, this part is great.
The auditor tracks its support rating for each side as it analyzes the arguments.
And it's a really dramatic arc. So on February 1st, 2026, the investigation kicks off. The auditor's confidence in Einstein is sitting at 99%.
Solid.
And the challenger is at a rounding error, 0.1%.
Yeah.
Standard physics is basically undisputed.
But by the end of the logs, the tables have completely turned. The auditor flips its support rating to 98% for the challenger,
Leaving Einstein in the dust.
It's a massive shift. So our mission today is to figure out why. What specific arguments, logical, geometric, mathematical, convinced an impartial auditor to completely rewrite the laws of physics?
Well, to understand that, we have to start where the auditor starts, with the concept of the map versus the territory.
This is the core accusation from the challenger, right? That physics has confused the description of the world with the world itself.
Exactly. The logs break this down into three distinct layers. You have the physical world, which is what is actually happening.
Okay.
You have the observation world, which is the data we get, what we see. And then you have the mathematical world.
The grid, the coordinates we use to describe it.
That's it. And the argument is that we've blurred the lines between them. We've started treating the math like it's the physical stuff.
Yeah.
I mean, specifically, let's talk about coordinates. If I hand you a sheet of graph paper, there's an x-axis and a y-axis. They're perfectly straight, rigid lines.
Sure.
In standard physics, we tend to treat space like that graph paper. We just assume the grid exists out there in nature.
But nature doesn't have grid lines painted on it. I've checked.
Right. The point cloud model argues that coordinate systems, they don't exist in the physical world. They're artificial. They're tools created by a describer.
A meta-observer.
Yeah, and when you assume the grid is real, you commit what the logs call the God's eye fallacy.
God's eye, meaning we think we're seeing everything at once.
Precisely. In a textbook, when you look at a diagram of a train moving, you're floating above the page.
Yeah.
You see the whole timeline instantly.
You see the train at point A and point B at the same time.
But in the real world, an observer can't do that. An observer is stuck in a seat.
A specific coordinate.
A specific coordinate with a specific viewing direction. And this is crucial. Once you lock an observer into a specific spot in the theater of the universe, they are subject to the speed of light.
They can't know what's happening across the room instantly.
They have to wait for the signal.
Which brings us to the first big technical point in the audit. The thunder analogy. The source uses this to really attack the idea of time dilation.
It's a brilliant simplification. Think about a thunderstorm. You see the lightning flash. 5 seconds later, you hear the thunder.
Right.
Now, do you turn to your friend and say, wow, time must have slowed down for that thunder?
No. I say sound is slow. It took 5 seconds to get here.
Exactly. It's a transmission delay. It's lag. But standard relativity treats light differently. When a satellite is moving fast, its internal clock seems to drift compared to ours. We call that time dilation.
We say time itself is warping.
But the challenger says, stop.
It's just lag.
Communication delay. Correct. The point cloud model argues that because the satellite is moving, the distance the signal has to travel is changing. The arrival time of that signal changes. Standard physics interprets that as a distortion of time.
But this model just says it's a delay in communication.
That's it. So we aren't dealing with a magical universe where time is all rubbery. We're dealing with a universe where the mail is just late.
And that appeals to Occam's razor, doesn't it? It explains the same thing, the GPS clock's drifting, without needing to invent a new fundamental property of the universe.
We're confusing the observation world, the delayed signal, with the physical world, the actual clock.
Okay, I can wrap my head around the time delay. That feels intuitive. But the auditor really starts to sweat when they get to the geometry, the shrinking train.
Ah, yes. Lorentz contraction.
The idea that objects physically get shorter in the direction of motion if they move fast enough.
To me, this has always been the hardest part of relativity to swallow. I mean, if I run fast enough, I don't feel like I'm getting flatter.
Chuckles. No, I hope not. The source material tackles this with a visualization they call paramanga, which is basically a flipbook test.
A flipbook.
Imagine a split screen. On the left, Einstein's interpretation. The train moves at near light speed and it physically crunches. The atoms get closer together.
And on the right?
On the right, for the point cloud model, the train is rigid. It never changes length. But, and this is the key, the observer's camera has to rotate to track it.
Rotation. This is the key word the auditor keeps flagging. Why does rotation matter so much?
Well, think about standing by a train track. As the train approaches, passes you, and moves away, you have to turn your head to keep looking at it, right?
Sure, I'm panning my head.
Your angle of observation is constantly changing.
And the logs present a geometric proof here. When you look at an object from an angle like looking at a pencil end on instead of from the side, it just looks shorter. That's foreshortening.
It's basic perspective.
So the claim is that Lorentz contraction isn't a physical shrinking. It's just perspective foreshortening, because we're looking at the object from a shallow angle.
That's the hypothesis. And the source gets very technical here. They propose a script for 3D software, specifically Blender. They separate the physical train, the white one, from the image train, which is yellow.
The image train being what we actually see.
Yes, the delayed projection. The script shows that if you just rotate that yellow image train to face the observer, it creates a pseudo-length. And mathematically, this pseudo-length matches the Lorentz contraction equation perfectly.
Wait, so the math is the same?
The numbers are identical.
That's the kicker. The equation, that famous formula. The auditor realizes it might not be describing a physical crush. It might be describing the angle of a visual shadow.
That is deeply unsettling. It implies we've been looking at a shadow on the wall for 100 years and thinking it's the object itself.
And that's why the auditor's support started to flip. It realized that standard theory requires a kind of magical physical change, whereas this model only requires standard geometry. But if you think that's wild, we have to talk about step 3.
The deflection shooting analogy. This was the part of the logs that felt like a logic puzzle. I had to read it twice.
It's a critique of the famous light clock experiment. You know the one. A light beam bouncing between the floor and ceiling of a moving train.
Right. In the textbooks, the train moves sideways, so the light has to travel diagonally to hit the ceiling. It makes a triangle.
Correct. Now, the source analyzes this setup like a sniper trying to hit a moving target. They call it deflection shooting, and they break it down into 3 steps.
Okay, walk us through.
Step 1 is the amateur move. You aim at where the target is now.
And you miss, because by the time a bullet gets there, the target has moved on.
Right. Step 2 is what Einstein does. You calculate where the target will be based on its speed. You lead the target.
And in the textbook diagrams, that's what we see. The light is aimed at the future position of the ceiling.
That sounds correct, though. You lead the target, you hit the target.
But there is a step 3, the recursive delay.
This is the dimension drop part, isn't it?
It's related. The argument is that light has a finite speed. It takes time to travel from the floor to the ceiling.
Okay.
During that travel time, the train keeps moving. The standard diagrams assume that if you aim for the future position, step 2, you hit it. But the source says standard theory underestimates the movement during the transit time.
Can you make that more concrete for me?
Okay, imagine you're a quarterback throwing a football to a receiver running downfield. You throw it to where they will be. That's step 2. But now imagine if the ball slowed down the further it traveled. The calculation isn't linear anymore. The source argues that Einsteinian diagrams are results-oriented. They draw the light hitting the ceiling because the theory needs it to hit the ceiling.
So they fudged the drawing.
The auditor calls it a logical flaw. The diagram works on paper because paper is 2D. This is the missing z-axis critique.
Yeah.
In a 2D diagram, you can hide perspective errors. But the moment you put this into 3D, where the observer has depth and distance from the train, the geometry fails. If you actually calculated the light path with the delay using the standard angle, you miss.
Miss the ceiling.
The light would trail behind the target. The step 2 calculation isn't enough. You need a step 3 correction to account for the delay of the light itself relative to the observer's depth.
So by ignoring this, standard theory is basically pretending the observer is everywhere at once again.
It goes right back to the God's eye view. We keep forgetting that we are watching this from a specific seat in the theater.
And once the auditor accepted that the standard diagrams might be geometrically impossible without that step 3 correction, well, the support for Einstein collapsed. It dropped to 1%.
Because if the geometry is wrong, the whole derivation of time dilation is wrong.
It's a domino effect. If the light clock diagram is a drawing trick, then the proof for time slowing down just evaporates. We're left with mechanics and delay.
So where does that leave us? If we strip away the warping space and time, what is the universe actually made of? The logs mention Maxwell.
The Maxwell standard.
Yes.
This is the reconstruction phase of the audit.
James Clerk Maxwell, 19th century, the electromagnetism guy.
The very same. Standard relativity got rid of the idea of an absolute reference frame. It said all motion is relative. You can't say who is really moving and who's standing still.
Right, if I'm on a train, I can claim the station is moving backwards.
The point cloud model brings back an absolute reference. It says, no, there is a floor. That floor is Maxwell's electromagnetic field.
So we aren't just floating in a void.
We are moving through a medium. The track, the train, the observer, we are all traversing this field. And this leads to a deep philosophical distinction the source makes between a point and a line.
Okay, this got a bit abstract for me. A point is an atom, a line is a history. What does that mean?
Think of a long exposure photograph of a highway at night. You see those streaks of red taillights, right?
Sure, lines of light.
But is the car a line? No. The car is a solid object, a collection of points. The line is just the history of where the car was.
I see.
The source argues that standard physics confuses these two things. It treats a light ray, which is a trajectory, a history, as if it were a static object, a point.
So we're treating the blur like it's the car.
Exactly. We're collapsing the dimensions. A point exists in the physical world. A line or a trajectory exists in the observation world. It's a record of travel over time. And by mixing them up, we create paradoxes.
So the name simultaneity point cloud, that refers to seeing the universe as a collection of these distinct points.
Yes, a cloud of points, each with its own coordinate, communicating via signals that take time to travel. It's a universe defined by signal latency, not by warping geometry.
It's incredible to think about the implications. We aren't saying the math of relativity doesn't predict things correctly. The auditor admits the numbers usually match.
The numbers match, but the interpretation is completely rewritten. That's the crucial takeaway. We replace time dilation with signal lag.
We replace space contraction with geometric perspective.
And we replace relativity with just delay.
It changes everything about how we visualize reality. We go from a sci-fi world where time is a flexible dimension to a world where we are just dealing with old news.
That's the delayed image concept. And this is the part that really stuck with me. The source describes our view of the world as a projection onto a time delay sphere.
Unpack that for us.
Imagine you are standing inside a bubble, and projected onto the inside of that bubble are images of everything around you. The image of the moon is 1.3 seconds old. The image of the sun is 8 minutes old. The image of the plane overhead is milliseconds old.
We know this, right? We know looking at stars is looking at the past.
But the point cloud model says everything is like that.
Yeah.
Even the coffee cup on your desk.
Yeah.
The light takes a non-zero amount of time to reach your eye. You are never seeing the cup now.
You're seeing a ghost of the cup from a fraction of a nanosecond ago.
And because we're moving, and the cup is moving, that ghost image is ever so slightly distorted.
We are navigating a map of past ghosts.
Precisely. The physical world is out there, happening right now, but we're trapped in the observation world, forever lagging behind it. The error of the last century, according to this audit, was thinking that the distorted ghost map was the actual territory.
That is a haunting image. It forces us to ask a really big question. If everything we see is just a delayed projection, do we ever actually see the physical world?
The source suggests we don't. We infer it. We reconstruct it. We're like pilots flying entirely by instruments, trying to figure out where the ground is based on delayed radar pings.
And for the last 100 years, we might have been calibrating our instruments based on a flaw in the manual?
A flaw in step 3.
Wow, a flaw in step 3.
It's a lot to process.
Yeah.
We've gone from simple map errors to sniper shots to a universe made of delayed ghosts.
It's a rigorous, difficult audit. And whether you agree with the findings or not, and I'm sure many physicists would fight this tooth and nail, it challenges us to look at the assumptions underneath the equations.
And that is exactly what we love to do here. We don't just read the map, we check who drew it.
Thanks for taking this deep dive with us.
Always a pleasure to check the coordinates.
Keep questioning the territory, everyone. We'll see you in the next one.